Welcome to qnawire.
So here we are going to solve question number 6.37. The diagram is same for the both question, but here we are going to solve 6.37. Okay, yeah. Now space truss with loading is shown in this diagram. The truss is symmetric about x and y axis, so we can solve only for half the truss. The other half will be same. Now here there is two supports, so because of this support there will be, let's take right, okay, there will be a reaction dx along x direction, and there will be another reaction along y direction, and in joint C along y direction there will be one reaction. Okay, and in joint B this is a pinned support, so there will be a reaction along all the direction. So along y, let's call it as by, and along x, let's call that as dx, and also along z, let's call that as bz. Okay, z direction. Now from symmetry, from symmetry you can notice that bx will be equal to dx. Okay, and also the by will be equal to dy. Now apply equilibrium in this 3D. So equilibrium equation, okay, that will be summation along x equal to 0. So that gives us 2 bx plus 2968, it's given in the question, Newton equal to 0, and yeah, so we know bx equal to dx, so from here we can find the dx also. That will be equal to minus of 1484 Newton. This negative sign indicates that the actual direction is opposite to the given direction. Okay, yeah, and summation along z equal to 0 gives us bg equal to 0. Summation at momentum along z at joint C equal to 0 gives us minus of 4.8 meter into 29668, right? Yeah, 68 Newton minus 2 into, that is the by, and dy is same, so that will be 2 into 2.8 by equal to 0. So from here you will get the value for by equal to dy equal to minus of 2544 Newton. Okay, yeah. Now let's go to joint A. For joint A, let's insert. So joint A connects members AB, AC and AD. Let's find the distances first. So AB will be equal to root of minus of 0.8 meter square plus 4.8 meter square plus 2.1 meter square. So root of this value will be 5.3 meter. Okay, and AC will be root of 2 meter square plus 4.8 meter square plus 0 square. Root of this value will be 5.2 meter, and the AD distance AD will be root of minus 0.8 meter square plus 4.8 meter square plus minus 2.1 meter square. Okay, you shouldn't put the sign outside because here there is square. Even though there is a negative sign, it got cancelled after squaring, but if you put the sign outside, the values will get completely changed. So you should remember that this will be 5.3 meter. Yeah. Now we got the values. Let's find the vectors. So first F A B. Vector FAB will be equal to magnitude of FAB into vector AB divided by AB. Okay, and we know the value of AB. We just calculated it. The AB is 5.3. Okay, and vector AB will be minus 0.8 I plus 4.8 J plus 2.1 K. So K is in Z direction and J is in Y direction and I is in X direction component. Now FAC, vector FAC will be equal to magnitude of FAC into vector AC divided by magnitude of AC. So that is FAC divided by, we just found the value of AC, that is 5.2 meter, times 2I plus 4.8 J. Okay, yeah. And next vector FAD was equal to magnitude of FAD times vector AD divided by AD. So this holds will be the magnitude of FAD. AD we know that is 5.3 times 0.8 I minus 0.8 I minus 4.8 J minus 2.1 K component. Okay, yeah. Now Yeah, first draw the figure. Let's draw the figure. So let's use, yeah. If this is joined A, then there will be FAC at this slope and FAD and FAB and the Q. Okay, drawing the question. Let's denote the direction also. Like this is y axis. This will be x-axis and this will be z-axis. Okay, yeah. So the component at I direction to find the component at I direction, we need to find summation along h equal to 0. So this gives us minus 0.8 divided by 5.3 times, let's come outside, FAB and FAD both are same. So FAB plus FAD plus 2 by 5.2 FAC plus the 2962 Newton. Oh, it's 68, okay. It's given 68. Yeah. Newton equal to 0. So we got one equation. So component at j direction for in j direction summation along a equal to 0 need to be found. So that will be 4.8 divided by 5.3 times, this is, let's take this common outside. So FAB plus FAD plus 4.8 divided by 5.2 times FAC will be equal to 0. So now let's go for the next step, that is along k direction. So component at k direction. So to find the component at k direction, we need to find some summation on z. Is that equal to 0? So that will be 2.1 divided by 5.3. Let's take this common outside. Then that will be FAB minus FAD equal to 0. So here there is 3 equations and 3 unknowns. So if we have 3 equations and 3 unknowns, we know how to solve it. So yeah. AC. Okay, so let's name this as equation A and this one as equation B and this one as equation C. Okay, solving these three equations, solving A, B and C gives us the unknown values, that is therefore F AC will be equal to 5510 Newton. Okay, FAC will be equal to 5510 Newton, and the FAC is actually going inward, that creates compression. Let's denote it by the letter C. And the FAB will be equal to FAD, and that will be equal to 2810 Newton, and the FAD is actually going outward from the point A, so that means that creates tension. Let's denote it by the letter T. Now let's move to the next one. Let's take that is joint B. So joint B contains members AB, BC and BD. Let's find the distances first. AB will be equal to, we already found the value of AB, that is we found AB from here, that is 5.3 meter. Okay, and about BC, that will be equal to root of 2.8 meter square plus 0 square plus 2.1 meter square. Root of this value will be equal to 3.5 meter. And next is BD. BD will be equal to 0.8 meter square plus 0 square plus 4.2 meter square. The root of this value will be equal to 4.28 meter. Okay, yeah. Now let's find the vectors. F A B, vector FAB. Actually, we found the vector FAB previously. The vector FAB is that value. Actually, we found the FAB by 5.3 into that value. We found what is FAB, the value of FAB. Just substitute that value in that equation. That gives us minus of, yeah, let's write it to avoid confusion. FAB into vector AB by AB. We know the values, so that gives us minus of 130 Newton along I minus 780 Newton along J plus 341.25 Newton along K. Okay, yeah. Now let's find the next one, that is FBC. Okay, let's find it. Vector FBC equal to magnitude of FBC into vector BC divided by BC, that is the FBC divided by BC is 3.5 into 2.8 I minus 2.1 K. So just divide it. After dividing it, you will get 0.8 I minus 0.6 K times FBC. Okay? Yeah. And about FBD. The FBD vector is actually the magnitude of FBD decay. Yeah. Now let's draw the figure. Yeah. Mm, let's take, of course, blue. If this is B, okay, then there will be FBC, FBD, and that was so close. And yeah, this is okay. FAB. Now let's draw the direction also using red. That will be good. Y, this is y-axis. This is x-axis. So this will be the z-axis. Now the component at y direction, component at y direction. To find the component at y direction, we will do summation along x equal to 0. So this gives us 24 plus 0.8 FBC minus 1484 after calculating equal to 0. So from here you will directly get the value of FBC, that is equal to 1325 Newton. And you can see the FBC is going outward from the point B. That creates tension. Let's denote it by the letter T. Okay, yeah. Now component at K direction, so component at K direction, we will find summation along Z. So this is actually minus of 1113, that is calculated. 0.6 FBC minus FBD equal to 0. So therefore we got the value of FBC, substitute that value here. So that gives us the value for FBC. FBD will be equal to 1908 Newton. And FBD is going inward, that creates compression. Let's denote it by the letter C. Now from symmetry, symmetry, we can actually write the value for FCD. Okay, FCD will be 1325 Newton. Okay, yep. And the FCD, FCB, yeah, FCB, FCB is actually going outward from the point B, so that creates tension. Yeah, so we got this value. So we got this value here. So from symmetry, this will be equal to FCD. Okay, yeah. I hope you understood the problem. Thank you.